All right, guys. Hopefully, you had some good discussion about the U.S. Senate compared to years past 22. Today, we're just going to kind of continue with our understandings with scatter plots, represent some bivariate data again, identify that positive, negative, and no correlation relationship scatter plots can have. Remember, positive relationships, generally speaking, have those dots increasing up and to the right, just like a positive slope, right? Negative means that those lines or those the scattered coordinates are decreasing as we move from left to right, right? Kind of correlating with the negative slope. And then you potentially can still have those ones that have no correlation whatsoever. So we're just going to talk a little bit again about what correlation and causation really means. Okay, so correlation is what we get with scatter plots. So there's a relationship, but it's not direct. The definition of correlation, and I pulled this off the internet, is just a mutual relationship or connection between two or more things. All right. The example, we talked about this a little bit in class, but studying for 2 to 3 hours per week correlates with a better test score. It does not cause a better test score. Okay. Now, causation, this is more in regards to a direct function. Right? The action of causing something. So the example I gave was earning 92 to 99% on an assignment causes me to get an A. There's a direct function involved where if you score between these two numbers, you will get exactly an A on the test or an A on the assignment. So the difference again is just correlation versus causation. All right. You think of a job, the hours you put in causes you to get paid. All right. It does not correlate because in a correlation, it may be a number of different amounts of money that you could get paid. Here's a little silly joke involved. All right. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class helped. Well, maybe. So again, that maybe part meaning maybe it caused it, but probably not. Okay. So we're going to look at a couple different examples, and again, just try and identify if this is correlation or causation. So the first one, the 10-day average noon temperature and the amount of geese on a lake. So I want you guys to think of if this would be correlation or causation. Okay, is the temperature causing a certain amount of geese to be on the lake, or is it correlated with a certain amount of geese on the lake, right? And in this one, this would be an example of correlation. All right. The next part of the question is estimate if it would be a positive, negative, or no correlation, right? Meaning that if the temperature gets larger, what does that do to the number of geese? So as temperature increases, do we think that there would be more geese or less geese on the lake? My thought is probably that if the temperature increased, we would start to see a positive trend. Okay, that the geese would actually increase. Letter B, number of hours worked at a part-time job and the amount on that individual's paycheck. So you could pause and kind of think about what you guys think that might be. Hours worked versus the amount on that paycheck. Would this be correlation or causation? And with this one, we're thinking causation. All right. Money is oftentimes a function of time. All right. Remember, functions are essentially like machines. So you put in your time and you get out that money. Okay. And then hours studying for a test compared to the amount of incorrect answers on the test. Would this be correlation, causation? And if it's correlation, what type? So we've talked about this example. This is correlation. All right. Next thing we need to ask ourselves is, as our hours increase, do our mistakes, do they increase or do they decrease? Okay. And my thought is as hours go up, the mistakes on the test probably go down. Remember, we're studying for more time. That means that our mistakes are hopefully decreasing. Okay? If not, you got to reevaluate what you're studying. Let's try one more example of that. So we've got years since 2009 and the amount of zebra mussels in a local area. So we want to think correlation, causation. If correlation, is it a positive, negative, or no correlation? Okay. So if we had years down here since 2009, 2 years, 4 years, 6 years, is the amount of zebra mussels increasing, decreasing? And if so, how much? Well, I don't think that the years are necessarily causing the zebra mussels to go up or down in thousands, but they definitely could be correlated, all right? So this would be correlation, right? And it might be a little bit of a mix. We've been taking some steps to manage those zebra mussels, but that is one thing that the DNR said was steadily increasing. So this would generally show a positive correlation. All right. Now what we're going to do on the next slide here is just create a quick scatter plot to kind of show that. This is just some data I pulled from a problem in a different math book to show kind of similar to what we were just talking about. So remember, in a scatter plot, the first step is choose your intervals, right? Label your axes. So we've got years past 2009 on our X. We've got number of zebra mussels in the thousands as our Y. All right, I chose intervals of 2s for the X and then 50s by my Y, just because of the numbers that I'm seeing. So I'll just throw these data points in. We got 1 and 15. So 1 and 15 is probably about there. 2 and 125 is going to be about right there. 3, 175. 4 and 225. 5 and 325. 6, 435. Oh, that one's going to be a little off our chart. And then 7 years passed, and we got 483. Again, somewhere kind of off our chart. So you guys can definitely see that positive correlation, positive trend. It says draw a line of best fit and use that line to predict how many zebra mussels would be present in 2039. So at this point, what we can do is use a straight edge to draw our line. I'm going to use just a pen. Use a different pen as a straight edge. This is a good straight edge if you ever get a chance to try it out. Okay, not bad. I would say not my best, not my worst. Once you've got your line of best fit, again, pick 2 coordinates that occur on your line. Choose them as your X and Y. So this is going to be after 4 years, 4 and 225. This one up here looks like this is my 7 and 483. All right. To write our line of best fit, we first start with slope. Y2 subtract Y1 over X2 subtract X1. So we've got the Y value subtracted by the Y value, X value subtracted by the other X value. So that's 483 minus 225 over 7 minus 4. Start with the easier one. 3 is going to be on bottom. 483, 225. So that's going to be, let's see, that's 8, 5, 2. 258 over 3. And to divide that number out, I'm just going to use Siri. Hey, Siri, what's 258 divided by 3?
258 divided by 3 is 86.
86. All right, so the slope of our line is 86. And that's 86 zebras per year. All right, based on this lake. All right, and that's actually 86,000, by the way. We are dealing with thousands of units, but we'll just keep that out of our equation. Now, next thing we do is we use point slope. So we've got, oh, there we go. y minus y1 equals my slope times x minus x1. Choose one of your coordinates here to use as x1 and y1. Geez, I labeled these correctly. That should be y1. I'm going to plug in 4 and 225. So this is going to read y minus 225 equals my 86 times x minus 4. Now what you can do with this is convert the equation to slope-intercept. We haven't required that, but we're going to show that here. 86x minus, let's see, 86 times 4 is 344, so minus 344 equals y minus 225. And the last step here is add that 225 to both sides. Okay. We're going to get y equals 86x. Let's see here, 344 minus 225. That's 14. That's 911. So that's minus 119 is my complete equation. All right, and that again just describes this line. This is a slope-intercept equation that describes the line. So a lot to it. Again, this would allow us to predict, 2039. Well, that's 30 years past 2009. So we could plug in 30 right here, 86 times 30, and then subtract 119 to figure out approximately how many zebra mussels there would be. Let's use our calculators here. Hey Siri, what's 86 times 30? Hey Siri, what's 86 times 30?
86 times 30 is 2,580.
2,580 minus 119. So we're dealing with 2,480, 2,470, 2,461, I believe, 1,000 zebra mussels. All right, just based on a small sampling of this lake. All right, hopefully this video was helpful. Again, you guys are kind of finishing up your understandings with ScatterPlots today. This is just one more example to kind of add to your bank. All right, have a good rest of your day, guys.